Hi there! In this video I'm gonna show you how to create a load rate app on IBM Cloud to send a Twitter alert message based on some sensor data sent from a remote IoT device. Here's the outline of this video. First, I'm gonna make a live demo to show you what the finished lab looks like. Second, I will quickly go over the system overall structure and the major components that we're gonna work on. Third, I will walk you through the entire procedure step by step. But before giving you the live demo, please allow me to briefly talk about the system overall structure. Basically, it's gonna have three layers: local, cloud, and end user. In the local, we are going to use something called a particle photon to connect sensor and publish sensor data to the cloud. Particle photon is a small form factor ARM Cortex-M microcontroller-based development board. Besides particle photon, there are many other options in the market you can choose from for building the local IoT device. On the cloud, we're going to use IBM Watson IoT platform to register the device. On top of that, we're going to create a load rate app to subscribe the sensor data, process the data, and trigger a Twitter alert message if the data is greater or smaller than certain threshold. The end user will be able to receive the alert tweet on a terminal device. By the way, you may have already noticed in the diagram I have this load rate app to send something back to the particle photon. But that's something we're going to do in the next step. I have another tutorial video to explain that. You can watch the details there. Now let me make the live demo. But first, let me turn on the webcam on my laptop and then you can see what I have in front of me. Okay, I have the circuit already finished. Here's the particle photon, here is a potentiometer. I'm using this potentiometer to mimic some real sensor like the one I'm holding here, which is a temperature and humidity sensor DHT22. The reason why I'm using, and I do suggest use a potentiometer here, is if you just use an actual sensor like this one here, it can only give you a fixed reading of your room temperature. Then you cannot trigger the alert message. But by using this potentiometer, you can manually change the potentiometer's position and trigger the Twitter alert message anytime. And I have some other LED indicators here, particularly this blue one. It's gonna blink every time while data is sent out by the particle photon. Alright, that's the circuit. In this live demo, I'm not gonna send the potentiometer's reading to the cloud. Instead, I'm gonna just send some dummy data starting from 0 all the way to 100, every time increased by 10. If the number is less or equal than 20, a lower temperature alert message will be triggered on Twitter. If the number is between 80 to 100, another high alert message will be posted on the Twitter. Let me power this thing up by connecting this USB cable to the host computer. And I have already flashed the code into the particle photon, and this one is booting right now, and you will see the LED, the blue LED, it's gonna blink anytime. Yes, here we go. You see this guy blinks already. That indicates some data has been correctly sent out from the particle photon. Okay, and then let me move on to the cloud and show you what's being received and what's the response coming from the load radar app. First one, let me open up the serial communication tool I have here with the particle photon. I want to see what actual data is being sent out from particle photon. And then I'm gonna open up my Twitter page. Okay, right now you may not be able to see the Twitter message coming out. Later we'll see it. And then let me go to the cloud and show you the load radar app here and the IBM Watson IoT platform page here. The visualization board on IBM Watson IoT platform already received and displayed the data coming from particle photon. Let me put this one together side by side with the serial communication, and then we can verify if the data is correctly received and visualized. Yes, here we go. We have 50 being sent from particle photon and then 50 being received and displayed here on the Watson IoT platform. And then next thing I'm going to show you is the load radar app. Let me open this up. That's the load radar app I created already. And then let me open up the debug view in the sidebar, and you can see already some data being received by the load radar app and some alert message being created. Let me delete them all and see any new things coming out. And here we go. There's something here saying the status is duplicated because that's from the Twitter. I believe the alert message has been created before, and then right now the code is keep running, and the same alert message is being generated. So the Twitter is reporting the status is a duplicate. Okay, let me put everything together side by side, particularly the load radar app's output, debug view, and the serial communication between the host computer and the photon. And then you can see what's being sent now from the photon is 5060, and let me delete this message here again to see. Yes, here we go. We have 70 being sent, and then 70 it's being correctly received by the load radar app. And the next one is 80 coming in. Yes, here we go. We have 80. 80 is a skip. And then we have 90 is being received, and then immediately a high alert message is being generated, and 100 is being received by load radar app, and then alert message is being created, and then 0, and then low alert message is created here. Warning, sensor readings, no current readings, 0. Here it's 0, here it's 10. We have 20 coming in, 20 being received, and there's a lower alert message being created. And then let's double check with the visualization interface on Watson IoT platform here. Yes, everything works perfectly. We have 40 here. Alright, very good. And then let's go to Twitter to verify any alert message being posted or not. Yes, here we go. I just refresh, and then we have the alert message being created. Okay, the reading 100, 90, 80, 20, and then scroll down. We have 0, 10. Okay, here we go. Everything's good. If you want verify, let me delete this message and then see if this high alert message 80, 90, 100 whether it's going to be created. Okay, Let me refresh this one and open up this one, and here we go. Look, I just deleted that alert message for 100 reading, and then this alert is created again. Okay, because over here we just have the 100 being sent out. Okay, everything works perfectly. Okay, last view of these three components: the particle photon, the IBM Watson IoT platform, and then the load rate app. 50, 40, 50, 60, 50, 60. Bingo. Alright, I think that's it. The three major components that we're going to work on to build a system as in the live demo. In the local, we needed to program the IoT device, which is a particle photon, to publish sensor data to the cloud. On the cloud, we're going to use the IBM Watson IoT platform to register and manage the IoT device. We can also visualize the sensor data on IBM Watson IoT platform. The data visualization is an optional step, but it can really help us verify what the data is actually being sent by particle photon and received by IBM Cloud. The third component is the load rate app. We're going to use the load rate to create an app on IBM Cloud to subscribe sensor data, compare the data with predefined thresholds, and trigger Twitter alert message. Here I have a diagram showing the detailed system structure. From this diagram, you can have an idea how these three major components are all linked together and work together. The particle photon is registered on IBM Watson IoT platform. With a correct authentication token, the particle photon can get connected with the IBM Watson IoT platform anytime and subsequently send data to the cloud through MQTT. Load rate and IBM Watson IoT platform are two different services running on IBM Cloud. The load rate app will be connected to IBM Watson IoT platform through the app's API key and authentication token. That's how all these three major components are linked together. Regarding the MQTT message flow among these three components, the IBM Watson IoT platform acts as the MQTT broker. Both particle photon and load rate app are the MQTT clients. Particle photon publishes the data to the cloud with an event topic. On the other hand, the load rate app subscribes the same event topic. So that's the reason why every time whenever particle photon sends the data to the cloud, and then load rate app can immediately receive the data. Now let's start the entire procedure. I have the first 5 steps here. Step 1. Log into IBM Cloud and launch Watson IoT platform service. Step 2. Create a device tab. Step 3. Register device ID. Step 4. Change the connection security setting on IBM Watson IoT platform to TLS optional. Step 5. Build a circuit to connect a potentiometer with particle photon. Verify the circuit connect photon to your host computer. I have a tip here. Use a potentiometer instead of an actual sensor for manually activating the Twitter alert message. If you just use an actual sensor, for example, a temperature sensor, you may not be able to activate the alert message because the reading will give you a one fixed reading of your room temperature. The 5 steps listed here are the same as in the last lab 6. You can refer to my lab 6 tutorial video, which I posted on the YouTube, for more details. To save time here, I'm gonna just quickly run through these steps. First of all, log into your IBM Cloud account. Click Catalog. Search IoT Platform Service. And I create an instance of the Watson IoT Platform Service. Because right now I'm using a light plan, so I can only have one instance per service. In order to create a new IoT platform service instance, I have to delete the existing one, which I don't want. Then let me just go to the dashboard and open up the Watson IoT platform service instance and then launch it. Right now I'm landed on IBM Watson IoT platform page. Over here you can add a device tab and add a device, which I have already done. That's the one I created already. I'm gonna use this one for today's lab. I have already saved the device credential when I registered that device. I'm gonna use this credential information later for writing Photon's code. Next thing you need to do is change the connection security setting on IBM Watson IoT platform. Make sure you set the default role as TLS optional, because that's the one we're gonna use in the Photon's code. Alright, the next one is to build a circuit, which I have already done. Now let me connect my Photon back on to my host computer. Photon is back on, and then let's move on to the next step. Step 6. Log into Particle Online ID, verify Photon's internet connection, use the registered device credential information, and program Photon to publish data to IBM Cloud. I have 2 tips here. Tip 1, you can refer to my Lab 6 example code posted on CityTech Robotics Research Lab website. Here's the link. Let me show you where you can find it. Go to citytechrobotics.org. That's my research lab's website. On the main page, click Teaching and then CET 4925 Internet of Things. Here's the web page for the IoT course offered at CityTech. I created this web page when I was teaching this course, and I put a substantial information and documentation there. You can go to weekly schedule and find the lab handout and some example code. The one we're gonna use is for same as the one for lab 6. Right under lab 6 here, you can see an example code for sending data for visualization on IBM Watson IoT platform. The code we're gonna use today For lab 7, actually it's the same as the one for lab 6. So you can just open this up. Here's the sample code. Use MQTT to send data from particle photon to IBM Watson IoT platform. In this sample code, I have substantial comments to explain to you what each line of code does. You can quickly go over. You can also go back to Lab 6 tutorial video on YouTube to see the detail there. I have already explained over there. Over here, let me just quickly re-explain which part of this code you need modified for your own needs for this lab. First, the host MQTT host port number, because we're not going to use TLS, so we choose 1883. If you use TLS secure connection, then you have to change it to 443 for IBM Watson IoT platform. And the next big segment of code you have to change is right here. That's where you need to provide the device credential information here, and then your particle photon can have a successful connection to IBM Watson IoT platform. First one is MQTT host. That's the link of the MQTT broker, which is the IBM Watson IoT platform. You need to put your organization ID here. The next one is MQTT client, which refers to your particle photon. Your particle photon will be one of the client to the broker, and the other one will be load rate app. We're going to set up the client ID over there later. Over here, you need to put your organization ID, device type, and device ID here. Another very important thing you need to set up is MQTT password, which is your device authentication token. The next thing you need to set up is the MQTT message topic. Over here right now in this example code, I use something called test data as the event name. You can change to whatever you want. And please notice that over here, the MQTT message topic specify the message as a JSON format. That means later in your code, you have to correctly generate a JSON formatted MQTT message payload. Another thing you may want to change is the payload set. Over here, I only specified 8 bytes string as the payload set. Another big part you need to change for your code for this lab is this one. In this example code, I only send out some test data starting from number 0 all the way to 400. Once the number hit 400, it will be reset back to 0. So if you have a potentiometer connected to your particle photon, you need to use analog read to get the potentiometer's reading, and then put it into the reading into a variable, and then later you can send out. Okay. A very important line of code you need to change is this one. Sprint payload blah blah blah, and then your data. This line of code is to generate the MQTT message payload by using some sensor data here, and then together with this string. This thing together gotta be ensured to follow the correct JSON format. You have a data property first, and then you have the actual value. Over here, I use test data as the data properties name. Of course, you can change it later to anything you want. And then the next line of code here is just actually send the JSON formatted payload. This client.publish is a function to be used to publish the data to the cloud. And you can see as two arguments. The first part is MQTT message topic. The second one is MQTT message payload. So pretty much that's what you needed to modify in this code for this lab. Let me summarize. The MQTT host port number, and then the device credential information here, also the MQTT host address, which is the MQTT broker, and then over here you may need to change the MQTT message topic and put your events ID or events name here. And if it's necessary, you may need to change the size of the payload. And now over here in the name code for generating the JSON formatted payload, you may want to change the data property. Okay. Pretty much that's how you can write up your code for particle photon. And then let's move on to the next step. Oh, by the way, I have a second tip here. Make sure taking notes of the event ID and data property used in the code, because the two parameters are very important and they will be needed by IBM Cloud later. Okay, let's move on to the next step. Step 7. Go back to IBM Watson IoT platform to create a board and a card to visualize the data. Note, when you set up a connect dataset for your card, make sure that event and the property fields exactly match what is being used in Photon's code. That's the reason why in the previous step I mentioned to keep a record of the event ID and the data property, because you needed to use those information right here. Okay, let me go back to IBM Watson IoT platform and I quickly create the board and a card. Let me call this new board as my demo board 1. And over here I'm not gonna set up anything to share this board with anyone. I just click submit, and here we go. We have my demo board 1 here. Open up, and there's no any card yet. So let me add a new card. Let me choose the card type as a gauge, and then select what device you're gonna receive the data from. That's the device I registered before, which we're gonna use here. My Photon 1. Click next, and then on this page we need to collect the data set. This is extremely important. We have to make sure the event ID match with what you have in your code, also the property. By the way, I have already copy paste the event ID and the data property and put in the record together with the device credential information here. Make sure the event and the property fields over here on this page are correctly filled, and then click next. Let me select the medium size of this visualization style, and click next. Let me change the title to something called, say, demo data from my photon 1 and click submit. Oh, here there's something missed. You must define a property name for each dataset. Oh, sorry, I forgot to click this. Here we go. Alright, and because my code is up and running there on my particle photon already, and then now you can immediately see some data being received by the IBM Watson IoT platform and visualized over here in this card. My photon is working already and successfully sent out the data to the cloud already. And here, let me quickly show you the photons code. Basically, you can just simply copy paste the example code from citytechrobotics.org website and then modify some part there. And let me show you what I did. Okay, here I have the correct MQTT host, and then the MQTT client, password, all have been correctly modified. And also I changed the MQTT message topic. I replaced the event's name by this thing called my test event. Another thing you need to change is this one, the line to generate the MQTT message payload. I changed the data property to something else. Over here I called my data property. Alright, another thing, I made some modification from the example code is here. In the example code I have something like this, the data property, and then colon, and then slash, quotation, and the percentage %d, and then the sensor data variable. And then I deleted this backslash quotation and another backslash quotation after the percentage %d. This backslash quotation together is actually output exact quotation mark in this payload. I did it here because I want to make this percentage %d to really make the data, dummy data, as a integer number instead of just a string. So that's another modification you may have to change. Okay, let me come out the original line. Let me zoom in this one a little bit and then make it larger. You can see here, let me repeat. Okay, if you want the sensor data be treated as an integer in your payload, as what I have here, then don't put backslash quotation mark, backslash and quotation mark, because this two quotation mark will make this sensor data here into a string. Later on the load rate app, because I want to extract this number out as an integer number, as an actual number, not as a string, so over here I'm gonna delete the two backslash quotation mark. Alright, that's something you can keep in mind. Okay, pretty much that's how you need to change the code for this lab, and then you can flash the code, which I have already done. Let me reflash. The code actually is correctly running right now behind. That's the reason why we can successfully visualize the data sent from the particle photon already. Okay, and then flash successfully. Let me refresh this one. And also you can open up a serial communication to see what actual data is being sent out from particle photon. Right now my photon is restarting, so nothing being sent out yet. Let's give it a few minutes. I just refreshed. Okay, here we go. Photon is now connected to IBM Watson IoT platform, and the data starting being sending out, and then the visualization here is success. Okay, we are done with this step. Let's move on to the next one. Step 8. Open your IBM Cloud dashboard. Open Catalog software, launch Loader app service. Create a Loader app. Note, during this step, you will also create a Cloud service, a secret store service, a developer tool service, and a continuous delivery service instance. Now here's the step where we're gonna create the Loader app. I have a warning here. Keep a record of your app's API key. Just as for device credential information, you can use a simple editing software to copy paste and keep a record of the API keys. The API keys will be very important. Alright, let's get it back to my dashboard page and launch the Loader app service to create a new Loader app. Click Catalog, click Software here, very important. Okay, you have to switch the tab from Service to Software. And under Web and Application, you can find the Loader app. Of course, you can simply just tap the keywords here and search right here, the Loader app. That's the service we're going to use to build a Loader app on IBM Cloud. You can click this and open up the starter page of the Loader app service. You can quickly go over this brief description, get a rough idea what this service is about. And what we're going to do is just to simply click this button to create a new Loader app. And over here you can name your app. Let me call this app as Loader app 1 IoT lab demo tweet alert. That's the name I'm gonna give to my Loader app. You can add something here for the text, but the name is skip that part. The next one is you can choose the region. I'm gonna choose Dallas. And then just click to create it.